When most people think of a system compromise, they picture a stolen password or a brute-forced login screen. An administrator account provides the highest level of authority within a system, allowing a user to delete other accounts, manipulate financial transactions, and view every piece of internal data. But modern attackers can acquire this exact level of control without ever stealing a credential or even visiting a login page. The most devastating vulnerabilities in modern networks exist in how systems silently process data, not in how they lock their front doors. Take a standard user profile page. The boundaries appear clear. You can edit your name or update a phone number, and that is all. Developers often rely on physically hiding administrative buttons and controls from this front-end view to keep standard users restricted. Beneath that interface sits the API, the Application Programming Interface. This is the underlying communication channel that actually processes the website's data. This shows the web interface peeling away to reveal the raw data pipelines connecting directly to the backend server. Attackers ignore the restrictive website entirely and send commands straight into these pipelines. If a platform relies solely on hiding buttons to secure its functions, it remains completely unprotected from direct API attacks. Consider a user initiating a routine action, like clicking Save Profile. If we freeze time the moment they click, we can examine the exact data packet leaving their browser. This is a raw JSON data packet. It contains basic variables formatting a user's name and a phone number. Using an interception proxy, an attacker can catch and hold this data packet mid-transit before it reaches the backend server. While it is held, the attacker manually types a single new line of code into the payload, explicitly injecting an administrator role assignment. The interception tool then releases the modified packet, allowing it to continue its journey toward the backend server. The attacker has successfully weaponized a routine profile update, disguising a system-compromising command within everyday traffic. Historically, web development required programmers to manually map every single user input field to its corresponding spot in the database. To speed up this process, frameworks introduced a shortcut called mass assignment, which automatically binds entire incoming data objects directly to database records. This shows the server processing node receiving the attacker's packet. It automatically absorbs all fields, mapping the injected administrator role directly into a database column without verifying permissions. The server instantly overwrites the existing database record, permanently elevating the user's status. Software engineering shortcuts designed solely to make development faster have inadvertently created a structural vulnerability where the backend trusts data it was never intended to process. The server returns a success status code, confirming that the profile update and the silent role change are both complete. This is the definition of vertical privilege escalation, a standard user successfully hijacking a higher-level administrative role. When the attacker refreshes their browser, previously hidden administrative dashboards suddenly unlock and populate with sensitive data and complex charts. The architectural fix is straightforward. Developers must explicitly define an allow list that specifies exactly which fields a user is permitted to modify. This illustrates a strict allow list in action. The filter intercepts the modified packet and drops the unauthorized role assignment while allowing the safe name and phone fields to pass through. In an API-driven environment, front-end security is an illusion. A system is only as secure as the strict boundaries enforced by its back-end data verification.